Find the function f at x that's a quadratic function given that the function evaluated at 1 is -1, the function evaluated at 3 is also -1, and the function evaluated at -2 is 14. This is an application that can be solved by using a system of equations. Essentially, we have three unknown quantities. We want to find the coefficients of this quadratic function, a, b, and c. And when we have three unknown quantities, we're going to need three equations that contain those unknown quantities in order to find a unique solution. With one unknown, we only need one equation. With two unknowns, we would need two equations. And with three unknown quantities, we would need three separate equations in order to find a unique solution. We don't have a whole lot of information given, but we are given three ordered pairs. Let's see if we can create the three equations that we need from these three given ordered pairs. So let's start with the function evaluated at 1 is equal to -1. And from this notation, we know that when we plug in x is equal to 1, the corresponding y value output is -1. So let's say here that we know y is equal to -1 whenever the x value is +1. So let's open up holes for each of these x's and plug 1 into each of those spots. And now we can see that we are actually going to be able to get three equations from these three given ordered pairs. The second equation is going to come from this scenario, which says that when we plug in x is equal to 3, we also get a y value output of -1. So we'll plug in -1 for y and open up variable holes for the x's and plug 3 into those spots. Our third equation comes from this ordered pair, which says that when x is equal to -2, y is equal to +14. So we plug in 14 for y and open up holes for the x's, and then we plug -2 into those variable holes. Let's clean this up and write it as a system of equations. So our top equation becomes a plus b plus c, and we want the constant to be to the right of the equal sign in order to create the augmented matrix that we're going to plug into our calculator. So our second equation is going to be 9a plus 3b plus c is also equal to -1. And our third equation is going to become 4a minus 2b plus c is equal to 14. So we turn this cleaned up system of equations into a matrix, and it'll be an augmented matrix where the columns are going to represent the coefficients on a, b, and c, and the constants are going to be to the right of the equal sign. So this first row becomes 1, 1, 1, and -1 in the matrix. Remember, we're looking at the coefficients on each of these variable terms, so all of them have a coefficient of +1, and then -1 is the value to the right of the equal sign. To put our second row in, we're looking at 9 is the coefficient on A, 3 is the coefficient on B, 1 is the coefficient on C, and -1 is the constant to the right of the equal sign. For the third row, we have 4 is the coefficient on A, -2 is the coefficient on B, and +1 is the coefficient on C, with 14 being the constant to the right of the equal sign. Now we want to put this into our calculator and convert it into reduced row echelon form. So we select second, and then the matrix button is in blue above the reciprocal button. We want to go over to the edit menu, and we want to edit the matrix that is in A. We need to tell our calculator how big our matrix is, and this matrix is a 3x4 matrix with 3 rows and 4 columns. So we say 3x4, it opens up a 3x4 matrix, and then we input our matrix starting with the top row. The top row of elements are 1, 1, 1, and -1. The calculator automatically then wraps around to the second row, and then we put in 9, 3, 1, -1, that second row. The calculator wraps us around to the third row, and we input 4, -2, 1, and 14. Then we want to exit out of here, so second quit, to the home screen, and then pull this matrix to the home screen to check our calculator input. So in order to do that, we'll select second matrix again, and this time we'll look in the names menu and just click enter next to matrix A, which is the first matrix, and then we hit enter again once we're to the home screen to display this matrix, and from here we're double checking our calculator input to make sure we got everything in correctly. Now we're going to operate on this matrix and convert it into reduced row echelon form. So we select second matrix to come up with the matrix operators that are in the math menu. So we need to arrow over to the right one and then go to the bottom of the list and look for RREF, the function with two R's. And we select enter. And once we have our reduced row echelon function, we need to say what matrix it is that we're operating on. And I'm going to use the answer variable since our matrix is on the home screen. I can access it pretty quickly by just saying second answer, and then close the parens and hit enter to get my matrix in reduced row echelon form. So this matrix in reduced row echelon form is 1, 0, 0, 1, 0, 1, 0, negative 4, and 0, 0, 1, 2. The calculator doesn't display the augment bar, but we should write it because the original matrix was augmented. And now it's time to return to the system of equations in order to interpret our answer. But remember, the variables in the system were a, b, and c, not x, y, and z. So these are a, b, c columns. And when we return to the system, this first equation becomes 1 being the coefficient on a, 0 is the coefficient on b, 0 is the coefficient on c. And so this first row translates to a is equal to 1. The second row has a 0 coefficient on a, 0 coefficient on c, and this is going to then translate to just b is equal to negative 4. In the third row, we have 0 as the coefficient on A and B. The coefficient on C is positive 1, and so this row translates to C is equal to 2. And now we're ready to write all of this as the quadratic function that we were asked to find initially. A is the coefficient on x squared, and we found A to be 1, so our first term is just going to be 1x squared. B is the coefficient on x, and we found our b to be negative 4, so that's going to be minus 4x. C is the constant value in the quadratic, and we found our value of c to be positive 2, so we have plus 2 on the end here, and this is the quadratic function that we were asked to find.